All right. Uh, oh,
Nope, we're good.
cool. All right. Welcome back, everyone, to episode 5 of This One Time. 5. So here we are. My name is Andrew Gillies. I am the CTO at Urban Machine, where we're reclaiming lumber at scale with robots. And I'm joined today by, as always, Jory Wisniewski, our marketing manager here at Urban Machine. The title of today's episode is Fast and Fundable. As you might notice, it's just Jory and I today, no one else from the team, and that's because we're going to be talking about when it was only me on the technical side of the Urban Machine team. This is going to be way back in August and September of 2021.
2021.
Yeah, yeah, and this is actually before we even incorporated Urban Machine. So this is like really the first few weeks. Eric and I had only been talking for like a couple weeks at that point. So we're gonna get into the very first thing that we ever built as part of the Urban Machine effort. Before we dive into the story, just a quick recap of what we're trying to do here at this one time with this podcast. Trying to share stories from the trenches of hardware development. It's really about just like pulling back the curtain a little bit and telling some of the nitty gritty details of what happens behind the scenes. I think it's easy to get sort of caught up in the big fancy demos that you see, but we really wanted to sort of reveal some of the challenging times and some of the big wins that we've had in our pathway. And really the hope is by sharing more of this information publicly about getting it out there that we could potentially help other folks accelerate their development process. We'd also love at some point to start hearing from other folks. I think that's sort of on our roadmap is to start speaking with folks outside of Urban Machine and hearing their stories. And just it's really all about just like moving down the field together a little bit faster. There's folks working on great projects and working on really challenging problems that we all need to solve. So hope is by sharing more of that information, we can all get to those goals a little bit
Yeah,
faster.
and build that community. I don't think I've told you this, but my nephew, one of his best friends, is an engineering student at University of Illinois, and my brother shared the show with him,
Yeah.
and he's been watching it and getting a kick out of it. So
That's great. That's amazing. Yeah, that's so
inspiring.
great to hear, right?
Yeah.
Yep, absolutely, absolutely.
Things
Yeah,
do go wrong, and or you have to think on the fly, or whatever the case is. Those are the kinds of stories we're trying to share and let everybody know that. Yep, we've gone through that too.
yep, yep. It's very normal. It's part of the process, and the most important thing is yeah, keep your eye on the prize and keep slogging at it because yeah, you're not going to figure it out on the first shot. You really do have to keep iterating and trying different things and trying new approaches, and that's really the fun part. It's being creative on a team with super smart folks working on hard problems.
For
Yeah,
sure.
yeah.
And today's episode is no different. Fast and fundable.
Fast and fundable, yeah. So today's episode is really about that very first benchtop prototype. So winding the clock back, August 2021, Eric and I had started to talk about, what we could do as an initial effort to demonstrate some technology traction. My role as CTO is really to chart the engineering, the technology effort, and the core of what we're trying to do is remove metal fasteners from lumber. That's really what we've discovered in our business is the key strategy and the differentiator between a lot of this lumber headed to a landfill and it being really high valuable material we can put back to work in our built environment. My background in hardware and robotics development, what I saw is really the two core challenges of the problem were a perception problem and a manipulation problem. How are we going to identify the fasteners in the lumber? How are we going to know where they were? How do we know whether they are present or not, or whether the lumber is clean? And then the manipulation problem is like, how do we physically get the fasteners out of the lumber? Um, and so the scoping for this initial prototype was one, it's got to be small. We're self-funded at this point, so we can't build this large giant monstrosity. It has to be something that think ballpark budget is like, $1,500, $2,000, which is, to personally finance something super risky is like, it's a little bit of money. It's a decent amount of money. It could be a lot of money for some folks. In terms of hardware development, that's like nothing, right? Like anyone, yeah, folks might blast that much on a single CNC component, so it's like an extremely tight budget. Um,
And you have nowhere to build this. Like it's not like you had the warehouse
we
that we
don't
have
have
to.
a space. We don't have our own office, so luckily, previous to Urban Machine, I was working as a contractor with other startups out of a space called Circuit Launch, which is this shared co-working facility down near the Oakland Coliseum, near the Oakland Airport.
Okay.
Um, and that was a huge resource for us. I'd been renting a desk there, so think of it almost like WeWork, except that everyone has hardware stuff all over their desk and there's 3D printers everywhere. It's like a super fun space. Yeah, we still maintain a presence there. They
That's
have
super
great
cool.
events all the time, and they provide a ton of resources to folks that were in exactly our situation, where they're incubating an idea. They might not have funding yet. Their budget is close to zero, but they just need some amount of space to get some stuff done, which you might not have in your apartment, or your house, or wherever you might be.
Sure.
So I had a little desk there, pretty much.
And just to so I understand, is there like tools for everybody to use, or you bring your own stuff?
It's kind of a mix. There's communal tools there. So they have larger, they have a suite of 3D printers you can use. They have a wood shop with drill presses, and table saws and chop saws. And they have laser cutters and electronics prototyping workbench. So they actually have a decent suite of tools there for sort of, I would call it light prototyping. You're not going to be doing any real heavy machining there. There's no CNC machines or lathes or anything like that.
Got it.
But if you're prototyping and tinkering and sort of like a 3D printed kind of style maker thing, then you're fully covered by being in this space. You could show up with almost nothing and get going.
Okay.
Yeah, yeah. So that was the perfect for us at this stage, right?
Sure.
Because like we're again $1,500, $2,000 budget somewhere in that zone. Like that, we're not going to be milling anything at that point. Yeah. So really the idea with this was like how can we show sort of the core element of this technology? How can we demonstrate that in like the fastest, cheapest way possible? So I gave myself basically a focus period. I was like, I'm gonna put my head down and really sprint on this for about 3 weeks. I think that was the timeline that I gave myself in like mid-August. Like, what can we show in 3 weeks?
Okay.
Yeah, and like just
And the
totally
3 weeks.
solo.
Is there a reason that 3 weeks was the number?
Um, yeah, it seemed like a reasonable amount of time to like get some progress without a timeline being so long that you could get like sidetracked or distracted. It seemed like, and that's sort of like a natural sprint time. Uh, Probably super aggressive and yeah, a little bit arbitrary. Mostly, I thought I could get it done in 3 weeks. So that was, that was part of it as well. Yeah. So that and yeah, a chunk of that too is just like waiting for parts to show up, right? Because you're like ordering stuff online and you're waiting for that to come in. So there's a little bit of like, usually these little sprints are like there's a little bit of upfront design and planning work, and then procurement. You're ordering stuff, and there's usually some activities you can work on in parallel while that's happening. But
Hmm.
then you got to wait for all that stuff to come in and then hammer it all together.
Yeah, I
Um,
get that.
yeah. So yeah. So the idea was, why don't we use as much off the shelf as we can, and demonstrate the core principle, which was like nail removal. Um, I definitely put a lot of constraints around the problem. Like we're not going to be able. That's one thing. Is just like you have to pick your scope really carefully with these things, right? Like you're not trying to boil the ocean. Just like pick off the very core element and just demonstrate that. So for me, the constraint was like we're only going to do it with like a little 2x4, and we're only going to try to show that we can remove nails that are like sticking straight out of the wood like a pegboard. Um, and maybe, Joy, you think maybe now's a good time to share the video, give,
Yeah,
give
I
more
agree.
context for the whole thing.
Did
So
Eric help you narrow that scope at all?
yeah, we chatted through and that
Like
was a part of the
most people.
conversation. Was
Hmm.
like there's always this like brainstorming around like, well, what could we show, what could we physically achieve with a budget and timeline, and then
Hmm.
the intersection of what do we think would be meaningful and valuable. Ultimately, we're trying to achieve two things with this demonstration. The first thing is to prove to ourselves that we think this is tractable from a technology perspective, that we can actually execute on this plan. That's the
Yeah.
first goal. And then the second goal is demonstrate to external funders to in our case we're raising venture capital to back our business, uh, to like go out to VCs and show them like, hey, we can actually do this. It's about fundraising, and it's also about like proving to ourselves internally that we can do it. And let's see. Here we go. So this is Splinter. So this is the result of that 3 week sprint. So what we're
I
gonna
would also
see.
like to say how much I love the name.
Yeah, I was pretty happy with that. I don't
Yeah.
know where that came from. For some like late nights working on this, thinking about names, and it just kind of materialized.
Perhaps the gods
This was
were
solidly before ChatGPT, so it wasn't like a it wasn't a LLM inspired
wasn't
name.
named by.
Yeah,
Yeah, yeah, yeah.
this was using the old meat brain meat based naming. Um,
I like it.
yeah. So what we're seeing here is there's this. It's effectively a glorified 3D printer with an off-the-shelf pneumatic nail removal tool on the front of it. So we have three axes. There's sort of an X, Y, Z axis, and then on the stage of the Z axis, I just literally zip tied this off-the-shelf nail punching tool to it. And
Okay.
then above that, there's a little webcam that's viewing the scene. You can see the view from the web. I inset the webcam here,
Yeah, yeah,
and
yeah.
yeah, so you can see this is like the robot's view of what it's seeing, and you can see sort of the blue coordinates streaming across there. What I did is I trained an instance segmentation model, so it's a machine learning model that
Okay.
I collected data myself, and I labeled the images myself and trained this thing, um, just to see like, can we detect nails in this scene, and can we pull coordinates off those nails with enough accuracy to like bring this gun down over them and shoot them out. And frankly, I was a little bit surprised. It only took about 300 images or so to train this first model, and it was pretty dang accurate. I'll play this again, but you can see here like the blue points. I did some post processing on it as well. So after I get the instance segmentation, I'm taking that little blob of where it thinks the nail is, and I'm running it through a computer vision pipeline using OpenCV. This was CV2, but like picking the middle coordinate out of that and then using that as the target point for the robot. And it was very, very accurate.
That's incredible. So that had to
Yeah.
be like pretty rewarding. And I imagine since you're in this like group space, are people like gathering around to see what you're building? Does it become like a
So select folks. I had a little partition around my office because we were pretty confidential at this point. But yeah, like certain qualified individuals, I would show the demo to. Yeah, there was a lot of oohing and awing at that point because it was like, wait, what? Like, there's a lot of like, what are you guys trying to do, and what is this crazy contraption? Like,
yeah,
where did this thing come from?
which is encouraging, you know. It's like you're impressing, you know, great minds around you and, you know, I would imagine.
Yeah, yeah. So it felt very good, and it really did. Once this came together, it was it was a strong signal that like, okay, if I can do this solo like this in a pretty short period of time, that like we with the sort of the pipeline, the technique that I had imagined, that like we had a good shot going forward. That like, okay, we can continually turn up, so to speak, turn up the volume and all of these elements, and really address a greater part of the problem, expand scope from this initial demo. Because like the first this first demo, like the vision system was pretty basic, right? Like here's the vision system, which was some LED strip lights that I had lying around, wired those up on either side of just a webcam that I had lying around. So you're talking,
How did you?
you know,
I was like expecting to see like a GoPro up there
yeah, right, yeah, exactly. It's like,
strapped
nope, I
on.
pulled it off of my laptop, slapped it on there. I didn't have the LEDs at first. I just had the webcam, but quickly realized that like controlling the lighting and just like having bright light over the thing really helped the model identify where the nails were and just gave me really consistent data,
Yeah.
which you know pretty early lesson for a lot of folks who are working on these vision systems. Just control the light. Yeah, there's just like a little laser cut acrylic plate bolted to the top of this slide. So it's like extremely basic and simple, but it was just enough to demonstrate that principle that like, okay, yeah, you can do this really basic components.
I feel like that's a lesson we've heard a few times on this show is that like that basic simple thing that you don't think is going to work is the thing that at least provides you enough information to show you the next level or the next step.
Yeah, exactly, and that's really the fast and fundable part, right? Is like we can do this really quickly. We don't have to wait for expensive components or long lead time items or some super complex process. Like just get a really early signal that you're headed in the right direction with what's lying around on the table. Uh, yeah. So I have another photo. Let's see, another photo here of the kit of parts. So this is kind of what the thing looks like exploded on the table beforehand. So this is, you know, you wait a week for stuff to come back. This is almost all from Amazon. So you just like blow it all out on the table, and then yeah, this is what turns into Splinter. So there it all is in its unboxed glory.
Awesome.
Yeah, yeah. So
No,
it
that's
literally is
awesome.
benchtop. The whole thing got assembled and tested on this one table.
One little table. I love it.
Yeah,
Yeah, I
yeah.
recognize some of those things. They've made it into the real design.
Some of the elements are there, right? Like
Yeah.
some of the things stick, for sure. Yeah.
But you've leveled up some.
A little bit, yeah. So like the camera is not a $50 webcam now. We have a very expensive industrial 3D vision system that's like $10,000. So yeah, we went up a couple orders of magnitude on that. We also went up orders of magnitude in performance, so that's part of the game is
Yeah.
doubling down, doubling down on direction. Be like, okay, let's squeeze as much out of this as possible.
Yeah. There is that expression. You have to spend money to make money, right?
Yeah, yeah, and in this case, it's yeah. The hardware for us is at scale in production. We're not super sensitive to that, right? Like any factory or capital equipment, once you're running material through a system, you pay that part off fairly quickly. So that's another part of the sliding scale, right? Is like the cost of goods and the cost of the prototype. You're very sensitive to in the early days when the budget is like literally zero. It's coming out of your own pocket. But then like as you start going towards production, at least for effectively a factory system like we're building, you're less sensitive to the cost. Different case in the consumer or other products where you're pinching every penny and you're squeezing every component.
Sure.
The cost down. For us, we're less sensitive to that.
So, you build this benchtop prototype, and did you bring it somewhere, or did you just video it and show the people you were pitching it to?
We brought investors to Circuit Launch.
To Circuit
That
Launch.
was that was our office in the early days. So they had a conference room there. So we would demonstrate.
Oh,
So we would show them the demo and then walk over to one of the conference rooms uh, and um,
discuss it.
and and have a discussion there. Yeah. So it was all at Circuit Launch in the first couple months. We did do a couple road shows with Splinter. So when Alex and Tyler joined, this was probably like October, November 21. Alex had this like, I don't know if he still has it, this like old trash car that they drove from Arizona. And oh, I remember, they wanted to get in and start learning the stack a little bit. So they actually took Splinter back to their apartment in Sunnyvale, and we crammed the whole thing into the trunk of his little sedan, and brought it down there so that they could start tinkering with
Oh,
it.
I have seen this picture. I've
I
seen
think there is.
Tyler. He's like this and
Yeah,
like pointing to the trunk, and I didn't know what
yeah,
that was.
yeah.
That's
That's it.
hilarious.
That's it. That's what was happening.
I know I'm gonna have to post that picture. I'll find it and post
Yeah,
that picture. It's
yeah.
actually on our website. It's on our timeline, the blog that I wrote about, like
Oh, it is. Okay.
the
Okay, that's
history of the
hilarious.
Roman machine.
Yeah, I think it survived exactly one trip. I think it like got down there, and then on the return trip, I think that was it. It was cooked.
Okay.
It was not super robust, as you can tell from
Well,
the zip ties all over the place.
you've learned from that as well because now you have the demo robot that does travel well.
That's right.
It's been to
Yeah,
Portland. It's been a few places in California now.
that's right. That's right.
And
Yeah,
really
and that
nice.
thing has survived the potholes of Oakland and San Francisco multiple times now.
That's, you know, people love a robot. They want to see it. So
Yep.
we have to
Yep.
keep bringing it around to places.
Yeah. Yeah. You gotta bring some. Yeah. Yeah. That's Yeah, the early benchtop efforts are super revealing though, right? And it's really about just like getting there and learning those first handful of lessons, and building sort of an intuition around the problem from
Sure.
a tech perspective. Just like, okay, in theory you could kind of stitch all these pieces together and get something to work, but it really it really helped me build a sense of like, okay, how precisely do we need to know the locations of those nails to actually bring an end effector in there and do it. And I played with a few different sensors as well. So one of the other sensors, actually, this is probably a fun video to share too, Jory. Uh, One of the other sensors I was playing with was a Microsoft Kinect, the 3D sensor, and that looked a little. So that same piece of wood, this is what 3D data looks like from it instead of 2D data. So what I'm doing here is I'm iterating through detections of various nails.
Okay.
And from some angles, this data looks pretty good. From other angles, you can tell there's a lot of sort of aberrations and like smearing of the point clouds. And this is what was like, okay, so there's this class of sensor. This can get us some of the information, but to really take it to that next level, we'll probably have to step up. So that, again, this is something we just tested on the benchtop with that same kind of setup. And then we're able to say like, okay, if we're really going to be able to do this, we probably need something that's just above this level of fidelity. And it's really just about like testing and getting there and showing it and saying like, yeah, okay, yeah, we can get this in here. We can isolate these parts of the point clouds. We can start extracting some 3D information. Yeah, with just like a little bit more investment, we can make it happen.
That's awesome. What a great revelation to be able to, build something, know that it works, know where to go from there, um, you know,
Yeah,
and be ready to start. That's incredible. And
yeah,
so quickly, like this is what I tell people all the time. I'm always so impressed by the fact that Eric had this idea in the middle of 2021, reached out to you, and here we are, a year and a half later, and you guys
yeah.
have already built three prototypes, and now the fourth iteration is the one that's going out into the field, um, starting later this spring, which is really, really exciting. So
It's been so
congratulations.
fast. Yeah, it's been
Very
so
quickly
fast.
started.
The most exciting part is just like how quickly we brought it all together.
Yeah. Well, you
Yeah.
guys work well together, and I think this show is actually part of like that. Not that the show is part of it, but like showcasing on this show that you do need to work together, and everybody's ideas are important, and listening to each other. Um, that's that's what builds a good team.
Yeah, absolutely. You're constantly finding the little like pockets of information and areas of compromise and the intersections of these ideas. And that's like how it's a big remix you're moving down the field with. Yeah.
Yeah, that's
Yeah,
awesome.
that's how you make it happen.
Yeah.
Yeah. Yeah.
Well, to learn more about Urban Machine, go ahead and visit our website, urbanmachine.build. And we, like I said, are going to start getting into the field later on this spring. So if you're in Northern California, and, well, even if you want to come visit the machine,
Yeah.
we can arrange that as well at our warehouse
Absolutely.
in Oakland.
Yeah.
Yeah,
Yeah.
very cool. Well, thanks for
Awesome.
another good episode, Andy.
Yes. Yeah. Thank you, Jory.
Fast and fundable.
That's right.
Out.
Yeah.
All right. Bye.
Bye-bye.